video, we will talk about power series. So starting with the definition, a series of the form sum from n equals 0 to infinity c sub n multiplied by x to the power n, where x is the variable and the coefficients c of n are constants in terms of x. Okay, so they depend on n, but they don't contain x, so they are constants with respect to x, is known as a power series centered at x equals 0. Okay, like c of n can be anything, so this can be, for example, I can have sum from n equals 0 to infinity 1 over n to the power 2 multiplied by x to the n. So in this case, this is cn, okay, and this is x to the power n. So the variable here is x. Now this is called, this is a power series centered at x equals 0. In general, this is a power series centered at x equal a. So if you make a equal 0, you get the form that you have above. Okay. Now here for simplicity, just so that we don't have any problems at 0 and a, we will assume the following, that this is always going to be c0 plus c1x plus c2x squared plus etc. So even if x is equal to 0 here, we're going to assume that x to the power 0 is equal to 1 always. So I can expand my series like this, and x minus a to the power 0 equal 1. So that's going to be always of this form, c0 when n equals 0. So x minus a to the 0 is going to be 1 plus c1 times x minus a plus c2 times x minus a squared, and this keeps going. It's an infinite series. So now we are making things a bit more complicated. We have, instead of having just a series, it's like we are multiplying some x to the power n or x minus a to the power n with this term. Okay, so these terms that you used to have previously are going to be just coefficients of the x exponents. So for example, sum from n equals 0 to infinity of x to the power n. So here you can see that what's cn in this case? Cn is 1. It's constant, which is 1 in all the cases. So sum from n equals 0 to infinity of xn is this series, 1 plus x squared, and so on. And actually, this is a familiar series. Okay, this is a geometric series with ratio r equal absolute value of x. Okay, and actually we know more about this, because if you have a geometric series, remember, so here I have x to the power n. Now this converges if this guy, if x is between -1 and 1, which is equivalent to say that absolute value of x is less than 1. So this power series is convergent if absolute value of x is less than 1, and we know it's divergent if x is greater or equal to 1. Why we know this? Because this is a geometric series, and we know this result from the previous chapter. So now here's what we are interested in. We're gonna be given a power series, and we want to find the values of x for which the series will converge, and the values of x for which the series will diverge. Okay, so here are again just some examples so that you can see these power series. So this is a power series centered at 0. This is power series centered at 0. This one is centered at 2. Okay, because this has the following form: sum from n equals 0 to infinity cn times x minus 2 to the power n. So this is centered at 2, where cn in this case is what? This is 1 over n plus 1 multiplied by 3 to the power n. And then you just expand it in this way. So since the terms in a power series involve a variable x, the series may converge for certain values of x and diverge for some other values of x, like we just saw for the for sum of x to the n from n equals 0 to infinity. So remember, this was convergent between -1 and 1, and divergent everywhere else. For a power series centered at x equal a, the value of the series at x equal a is given by C0. Therefore, a power series always converges at its center. So you guarantee that you have one value of x that will make it convergent. And this is the center. For example, if you take the series sum from n equals 0 to infinity, c sub n multiplied by x minus a to the power n. Okay. If you let x equal a, what's going to happen here? Remember that we said at the beginning that this is going to be c0 plus c1 times x minus a plus, so we will always assume that that x minus a to the power 0 is 1 plus c2 times x minus a squared plus etc. Now if you make x equal 0, if you make x equal a, then this becomes 0, this becomes 0, and so on. So basically, when x equal a, the answer is going to be C0. So the series is convergent because the sum is finite. Okay, so every power series will converge at its center. If the center is a or 0, it's going to converge at that value. So you have at least one value where the series will converge. Now, most power series converge for more than one value of x. Some of them, they converge for all real numbers. Some of them, they converge over a finite interval. So that's something that we will see. So for example, the series sum from n equals 0 to xn converged over this interval, which is a finite interval. We will see some other series that will converge over some infinite. So they will converge no matter what x. You can plug an x to be anything. So here is the possible situation that we can have. In general, we are given a power series centered at A. You can have one of these three possibilities, no fourth. The series converges at x equal a and diverges for all x different than a. That means only at the center, only at its center. The other possibility, the series converges for all real number r, for all real numbers x. So x can be anything. Okay. The third possibility is very similar to the case of the geometric series. The third possibility is it will converge when the absolute value of x minus a less than some number r. You will see how we can find this number, and diverge otherwise. Now here there's an important thing you have to be careful about. So for example, I can say that x minus a less than r converges if x minus a less than r. What does this mean? This means that x minus a is between r and minus r. Furthermore, this means that x is between r plus a and minus r plus a. Okay, so x will converge right here, and according to this, it will diverge. So let me show you this. Suppose I have a number line. Let's say this is minus r plus a. Let's say this is r plus a. So we are saying that x converges right here and diverges right here and right here. But there's something missing here. What's going to happen at these values? Okay, this is something that it could converge at one of them, it could converge at both, it could diverge at both. So that's something that we will have to check separately. Now, if the series falls into case 3, the one that we just discussed of the previous theorem, then the series will converge for all values satisfying absolute value of x minus a less than r Of course, r has to be positive in this case, and diverse for absolute value of x minus a bigger than r. The series may converge or may diverge at these values. So these are the values that I showed you on the intervals. These are the endpoints of the interval. We're gonna call this the interval of convergence. Okay, so the values of x for which the series sum from n equals 0 to infinity Cn x minus a to the n converge is known as the interval of convergence. So for example, when we considered the geometric series sum of xn from n equals 0 to infinity, the interval of convergence was -1, 1. Okay, and here we define also something called the radius of convergence, which is just half of the length of the interval. Okay, the length of the interval is 2r. So therefore, the radius of convergence is r. So for the previous, for the geometric series, we said it's from -1 to 1, and it's centered at 0, sum of xn from n equals 0 to infinity. This is a power series centered at 0. So the interval, you will always have this case that the center is going to be in the middle of the interval. Now, as I said, we don't know what happens at the endpoints. We have to check it. But for the geometric series, we know that at the endpoints, it diverges. So this is the interval of convergence from here to here. Okay. So the r is half of the length. So r is equal to 1. So here r is equal to 1. The radius, this is called the radius of convergence, which means 1 from either sides of the center. Okay, so here this is the example that we just discussed, which is the that's the interval of convergence, and that's the radius of convergence for the power series. So these are the three possibilities that we just spoke about. The first, this falls under the first case. So here this converges only at the center. Over here this converges. So when this converges only at the center, the radius of convergence is equal to 0. When the series converges for every value of x, so here interval of convergence, is r, which is -infinity to infinity, and the radius of convergence is infinity. Over here, the interval of convergence is from a minus r. Well, I don't know if it's gonna be from if I'm gonna include, so possibly I can include or exclude these. Okay, so I don't know for sure. That's something that I cannot claim. Okay, but the interval of convergence is gonna be from a minus r to a plus r. It could be this, or it could be this. Same thing here. It could be closed or it could be open. One of them. That's something that we will discuss. And in this case, the radius of convergence is r, as it's shown right here. So consider the following problem. We are given a power series and they want us to find the interval and the radius of convergence. So once you get the interval, then the radius is very simple. It's just half of the depending on the case, whether if the interval is finite or no. Most of the times, when we want to do this, we're gonna follow the same thing I will do in this example. We're gonna use the ratio test. Okay. Now, I will take the limit of an plus 1 over an. So I'm thinking of this whole thing as an. So you can see that an plus 1 is going to be x to the n plus 1 over n plus 1 factorial divided by xn over n factorial. You can drop the absolute values because all the terms are positive. Dividing by a fraction means multiplying by its reciprocal, as you can see. Here you can cancel. Remember, n plus 1 factorial is n plus 1 multiplied by n factorial, so you can cancel n factorial from here and here. This is x times x to the power n. You can cancel xn and xn. So you end up with x over n plus 1. I don't care what's x, positive, negative, 0. When I divide this by n plus 1 and n goes to infinity, my answer is going to be 0. So this is less than 1 always. Now, when you find this limit L, which is the limit of a absolute value an plus 1 over an, and you get 0, which is less than 1, that means it's convergent. Actually, it's absolutely convergent by the ratio test. Then here, I don't care what's x, I'm always getting convergence, meaning that x could be anything. That means that the interval of convergence can be anything, which is negative infinity to infinity. And if the interval of convergence is from negative infinity to infinity, then the radius of convergence is infinity. So here, this is done. Okay, so this is the best situation that we can have. Okay, that it will converge no matter what x is. Now, I can tell you one thing here. If you recall, when I was talking about the sequences back when we started talking about sequences, I mentioned in one of the slides, I said that the limit of xn over n factorial is equal to 0 when n approaches infinity. Now, the proof was a bit complicated because I was breaking this into cases and so on, and I said I'm going to give you a much simpler proof when I talk about series. So that's the time here. Look, what I know from here is that this is convergent. When? Always, for all x. Okay, now if the series is convergent, then the term must go to 0. Then this must go to 0. Because if this does not go to 0, then that's not going to be convergent, and this will contradict my result. Okay, so this as a limit is going to go to 0 when n approaches infinity. Because if not, then by the divergence test, this is going to be divergent, and that's not possible. Okay, here's another example. Find the interval and radius of convergence. We're going to use the ratio test again. This is going to be my an. In this case, we're going to find the limit of an plus 1 over an. Again, you can drop the absolute value over here. So what happens is that when I write there and simplify, I end up with the following expression. Now, the absolute value of x, that's a positive number. Okay? And this number is multiplied by infinity, so my answer is going to be infinity. What does this mean? This means the following, that the series is going to be divergent because the limit is bigger than 1. Remember, so here I'm applying the ratio test. Remember, in the ratio test, if the limit is less than 1, converges, absolutely convergent. Bigger than 1, divergent. So certainly this is bigger than 1. The only problem is when it's equal to 1. That's when the test is inconclusive. So the interval of convergence here is just at x equals 0. Remember, here I said x positive. When x equals 0, that's a special case. 0 times infinity is not defined as a limit. So here, when x equals 0, that's going to be convergent. And so this is going to converge only at the center because x equals 0 is the center. And in this situation, the radius of convergence is r equal to 0. So we have seen the case when the interval of convergence is just the center, and that's the least possible, smallest possible interval. And we have seen the case when the interval of convergence is from negative infinity to infinity, and that's the largest possible interval. Now, we consider the following. This is not going to be similar to the previous two cases, as you will see. Again, we use the ratio test. Okay, so this is my a sub n. I'm finding the limit L absolute value of an plus 1 over an. You can see what I'm writing right there. Then here I flip the fraction. Now I need to simplify. Now notice something, that this is equal to x minus 2 multiplied by x minus 2 to the n. So this cancels with this. N plus 2 and plus 1 doesn't cancel, so just keep it the same. This is 3 to the power n times 3, so this cancels with this. So the leftovers are x minus 2 and n plus 1 from here. Okay. I think I have a typo here. It should be the n plus 1. This doesn't change my answer over n plus 2 like this. Okay. Now you have to keep the absolute value. Okay. I'm dropping the absolute value for well, actually, this is the limit when n goes to infinity. So let me write it here. Just absolute value of x minus 2 multiplied by n plus 1 over n plus 2 multiplied by 3. Now, the only thing that I don't know its sign is x minus 2. Okay, everything else is positive. N plus 1 is positive, n plus 2 is positive, 3 is positive. That's why I can drop the absolute value over all these three numbers except at x minus 2. You have to keep it. Now, when the limit when n goes to infinity, look, this is for n with respect to n, this is like a constant. Okay, and this guy goes to 1 when n goes to infinity. So my answer is this. Absolute value of x minus 2 over 3. Okay, now here's what we can conclude now. The limit L, which is the one for the ratio test, is equal to x minus 2 over 3. When does it converge? Well, this converges when the limit is less than 1. So this is absolutely convergence over here. Okay, so what does this interval means? Just here, this means the following. That's something you should recall, how we write the inequalities with absolute value. This means absolute value of x minus 2 is less than 3. Now this inequality can be written, or this actually means the following, that x minus 2 is between minus 3 and 3. Now the radius of convergence, I can see the radius of convergence is 3. Okay, because this is originally this was centered at 2 and x minus a is less than r. If you recall the definition, x minus a is less than r. That's the radius of convergence. In my case, I got x minus 2 less than 3. Okay. Also, we can visualize this on the number line. So this means that x is between minus 1 and positive 5. So any x I choose here, this is very important, any x I choose between minus 1 and 5 is going to lead to a limit less than 1, which is very good. Any x I choose over here or over here bigger than 5 or less than -1, it's going to lead to a limit bigger than 1. And according to the ratio test, that's divergent. Now the only thing I have problem with is when the limit is equal to 1. And this happens when the value of x is -1 or when the value of x is 5. Because if the limit, if x is -1, plug it in here, you get -1 minus 2, which is -3. Absolute value of -3 over 3 is 1, and same thing for 5. Now why I have problem? Because when the limit is equal to 1, the ratio test is inconclusive. It doesn't tell me anything. So for these two values, I have to do them separately. So here we're saying that the series converges absolutely if x is between -1 and 5. If the limit is bigger than 1, then the series will diverge. So therefore the series diverges if x is less than -1 or x is bigger than 5. Now we're not done yet. As I said, the ratio test is not conclusive, so it's inconclusive at L equal 1. So L equal 1 if and only if x minus 1, x equal minus 1 or x equal 5. Why? Because remember L was equal to absolute value of x minus 3 over, what was it? X minus 2 over 3. Okay, so this is equal to 1 means what? Means absolute value of x minus 2 is equal to 3. Solve this absolute value equation. So this is this or this. So this means x equal 5 or x equal minus 1. Okay, so L is equal to 1 if and only if I got these two possibilities. So we need to test these values of x separately. So that means I need to plug in x equal -1 in the power series, and then I get a regular series and see if it's convergent or divergent. And then I have to do the same for x equal 5. So then, so till now, I know the following. I know that over here it's convergent, over here it's divergent, over here it's divergent. I also know that the radius of convergence is 3. Again, there's more than one way to find it. You can just, after you find this interval, 5 minus the size of the length of this interval is 6, divided by 2 is 3. Now my only problem is what happens here and what happens here, so that's what I will investigate next. So recall that this was the power series given. Okay, so if I plug in -1, so I'm going to start with x equal -1. If I plug in -1 for x, I get the following series. Okay. I have a typo here, sorry. If I plug in, oh no, I don't have a typo, sorry. If I plug in x equal -1 here, I got this. How did I got this one? Well, it's very simple here. If I replace this with this, that's gonna be -1 minus 2 to the power n over n plus 1 times 3 to the power n. So this is the sum from n equals 0 to infinity, -3 to the power n over n plus 1 times 3 to the power n. Now I can make these as one exponent because both of them are raised to the power n. So that's the sum from n equals 0 to infinity, 1 over n plus 1 multiplied by -3 over 3 to the power n. Now -3 over 3 is -1. So that's how I got that form. Okay, well, this is an alternating series. We've seen something like this before. It's an alternating series and it's convergent. How it converges? It converges by the alternating series test. Because in this case, you have sum from n equals 0 to infinity, -1 to the power n times 1 over n plus 1. This is Bn. Clearly here, Bn is positive. Bn is less than Bn plus 1 is less than Bn, because Bn plus 1 is 1 over n plus 2, and Bn is 1 over n plus 1, so this is less than this. And limit of Bn when n approaches infinity is equal to 0. So by the alternating series test, this is what? Convergent. So this is convergent. Then at x equal -1, the series will converge. So I'm going to include this to my interval. I'm going to add this endpoint to my interval of convergence. Now what happens when x is equal to 5? In a similar way, when x equal to 5 here, what's going to happen is that becomes sum from n equals 0 to infinity, 5 minus 2 to the power n over n plus 1 times 3 to the n. 5 minus 2 is 3 to the n, so that's sum from n equals 0 to infinity, 3 to the n over n plus 1 times 3 to the n. Cancel this with this, you end up with this series. Clearly, this is divergent. Okay, this is divergent. You can compare it to the harmonic series using the limit comparison test. So, as a result, the series is convergent when x is from -1 to 5, and including -1, excluding 5. So the interval of convergence is from -1 to 5. So now, this is the interval of convergence. Okay, so it's converged right here. over this interval, diverge right here, and diverge right here. You can see the endpoints, 5 diverge, -1 converge. And we knew from the beginning that the ratio was 3, so that was easy to find.